2.2. Gosh, it's been a long lesson. This is part 4 of 2.2. So hopefully we knock this thing out and finish it today. We'll hopefully reach that goal. We're going to talk about paired data sets. You guys have done this before, right? If you had, if you were graphing something where maybe something changes over time, you know, every minute, right? The growth of a bean plant or something like that, right? On day 1, it's some inches high or some centimeters high, and then on day 2, and you graph its growth, right? You see this graph with these scatter plots that kind of go up, right? As you go to the right, you notice that your dots go up, that kind of thing, right? That's what this is. So we have this situation where we're interpreting a scatter plot. So Fisher's iris data set, various physical characteristics such as petal length and petal width for 3 species of iris. The petal lengths from the first data and petal widths from the second data set. Petal lengths from the first data set and then petal widths. There we go. So, how would we arrange this? Conveniently, it has already been written there. Right? That we would have petal length and petal width, and that's going to be like, that's going to be our x, right? And that would be our y, right? So this is going to be on our horizontal axis. And this is going to be on our vertical. That's it. They're just kind of wanting us to interpret it. What would you make your your x and y? Okay. Yeah. So sometimes that's called an explanatory and a response variable, right? Other times it is called your oh my gosh, I'm so used to AP stat that I haven't even that it's been a while since I have said the mathematical version of it, which is independent and dependent variables, where your independent variable is your x and your dependent variable is your y. Sorry, it took me a little while to jog memory. You what? Oh no, I couldn't hear you at all. No, I would have loved to. Okay. Sorry. All right. Okay. Hey, as the petal length increases, what tends to happen to the petal width? It increases, right? We see a this positive trend, right? As our x variable values increase, our y variable values increase. You don't have to copy this down. We'll do one ourselves, and that's when we'll get in there. All right? Okay. And that's just what we said. Okay, here we go. We've got the lengths of employment and salaries of 10 employees listed in this table. We're going to graph the data using a scatter plot and then figure out what we can conclude. So go ahead and write this table down, and we're going to graph this. Yes. Independent. X is independent, Y is dependent. But really in statistics, you want to call that the explanatory variable and the response variable. Explanatory and response. All right, so let's graph this thing. I'm actually going to do it rather than have us look at that. Here we go. I kind of feel like making some nice straight lines. What do you think? Wow, that was not bad. Just a little tilty, huh? Didn't fix that. Alright, cool. So, when we're gonna make a graph, we should definitely figure out a title, and we should label our X and Y axis. So what was X?
X is the length. Yeah. Length of employment years.
Okay. Length of employment. We'll say in years. And our y-axis, or our explanatory, or our dependent variable, right? What was that label?
Salary.
Salary. And then let's get a title on this thing. We could just call it employment salary graph. Emily, what the heck? Employment salary graph. All right, those are important things to include. Okay, if you don't include a title and label your axes, then it is not right. It's a scatter plot. Dot plot is what we made when we had one variable and then we had a frequency. A scatter plot is going to be bivariate, or two variable data, right? So we have two variables, X and Y. Those are our two variables. All right. We have length of employment in years, and this was just going up with just by single digits, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What was our highest value? 10. All right. Well, there it is. Have a little extra X there. And what was our lowest X value and our highest X value?
40. 25.
25,000.
100.
Okay. So let's go ahead and go by. Let's see, if we go by 5,000, is that going to be good? No, let's.
I started at 25,000 and went by 5.
So you got to be careful. If you're going to skip a bunch of area down here, you need to make some sort of a. There's a way to do that. You have to actually put a little squiggly there that says that you skipped. But just to avoid that, let's just go ahead and start at 10,000. So we'll go 10,000, 20,000, 30,000, 40,000, 50,000, right? And we're gonna denote what these are: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then over here we'll go 10,000, and let's go in thousands. That way I can go 10, 20, 30, 40, 50. Cool. All right, so what was our first data entry point?
25,000.
2, so it was X is 2?
Yeah.
25,000, okay. And next?
28,000.
328, there we go.
4, there's 2 4s, but
Okay.
this one is 27,000.
4, 27.
Yeah, and then another 4 is 32.
4, 32. So these two dots should be in line, right? So you have two dots that'll be in line. All right. Next.
Are we at 5?
Are we at
32,000.
532?
Mm-hmm.
All right. What's next?
6, 39.
639. Okay. 741.
840.
840.
945,100.
Oh, you're, well, sorry, 8, and what were we at? 8 what?
8 was 40,000.
And 9?
45,100.
45. Okay. And then 10.
43,000.
All right, and there it is. Oh, you did it.
A little bit like
Oh, okay, but it is so important to label everything.
yeah.
Okay, everything needs a label. You have to label all of your units, right? The 1, 2, 3, 4, 5, 6, the 10, 20, 30, 40, and I have to put in thousands if I'm gonna abbreviate like that, right? Also, you need like labels with that tell you exactly what each variable is. All right.
Is it okay for like something like numbers higher?
You can. It gets a little. Yeah. Okay. But if you're gonna put the numbers, on a graph like this, you have to represent them as coordinates, actually, right? So it's a little weird.
So I'd do 1.
Yeah, exactly. Yeah, because these are coordinates now. All right. Everybody got that? Need one more time? Got it. Let's go on. Oh, look, there. That one. Mine looks better. All right. And that's kind of a nice way to look at it as well. All right, time series. So we're taking these at regular intervals over a period of time. And then we'll use our time series. So we will actually, the difference is it makes sense when we're doing this to actually connect each one of these points. Because that connection shows like to connect it with a line. That connection shows whether we have some increasing trend or some decreasing trend. So it's meaningful. With a scatter plot like we had before, you wouldn't really want to connect those points. Because it's strange, right? We had, especially where we had, at 4, we had 2 points for the same x value. We had 2 separate y values. It would be weird to try to connect these, right? So it makes sense for a time series to connect. Okay, so we've got an example. We have the number of cellular telephone subscribers in millions for the years 1998 through 2008. We're going to construct a time series chart for the number of cellular subscribers. All right. So it looks like, right, our x-axis, right, is going to be time in years, and then we're looking for a number of cellular subscribers. So that's why we have this data over here on the left-hand side of the table circled, because we're going to go ahead and ignore the average bill data. We're just going to make a time series for a number of subscribers. Yes? No, we'll construct one. This is like you get to see it, and then we'll construct. All right. So just like I said, horizontal axis is going to represent years. We have a number of subscribers in our vertical axis. And then we're going to plot this pair of data and connect them. Instead of line segments, what would that look like? It would look like this. And here we go. Very cool to show you that this right here, this symbol, you You've got to use that if you're not going to start at 0. You've got to use this if you're not going to start at 0. So we didn't start at 0. It would be weird if we did, right? We would have like a bunch of entries, you know, thousands of entries leading up to this. So one way to get rid of that is to use that. Another way to get rid of that is to just say, hey, 1998 is year 0, right? So you could go 0, 1, 2, 3, 4, but you have to say, hey, 1998 is your first year, right? So you could also avoid that. But that's what that's going to look like. So we'll try it ourselves. There you go. Same thing, right? We have average. Oh, what in the world is going on there? Okay, let me read that. Average bill in dollars for the year. You can imagine. What do you think is going to happen with this data? As your years increase, right? What do you think is going to happen to your bill? Your bill should increase, right? So we should have this positive trend going on, right? And go ahead and get this down. All right, so I can make a better looking one than that. All right, so we got to remember when we're making this to put the little break here, and then our years are going up by ones, right? 1, 2, 3, 4, 5, 6, 7. It starts at 1998.
There's 11.
98, 99, 0, 0, 0, 1, 0, 2, right? 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, and it ends in 2008. All right. And this is year. And we gotta say in thousands. And this axis is gonna be cell phone bill. Units we're gonna use for that. So let's go 5s. 5, 10. I'm gonna need to go 10. Otherwise, we're gonna run out of room. Let's go 10, 20, 30, 40, 50. What's our max value?
0.
All right, that works.
69,
We'll go 60. So 10, 20, 30, 40, 50, 60, and this is in dollars. So our units are dollars. That's pretty bad dollar sign. Maybe I can make it better. Maybe not. All right. Okay, our first data point was 98 what?
39.43.
All right, next one. 99.
41.24.
Thank you. 2000.
45.27.
And 2001.
47.27.
2002.
48.40.
Kind of don't like it. That's not lining up right. There we go. Okay. 2003.
49.31.
2004.
50.6.
2005.
49.98.
2006.
50.56.
2007.
49.74.
And 2008.
50.
All right. So as we began, as we connect these, we can see that there is a fairly positive trend. And then we get into the 2000s, and we start to have this trend where it fluctuates, goes up and down. So that's kind of what you want to see from that. All right. You know what? It's so exciting today that we just about finished. You guys need to write this down. Yeah. All right, y'all. So that's the other one. There's a computer output of that. You can make something like this using Excel, some sort of computer program. There it is. Your classwork assignment for this. We'll work on that during our next class. Not too bad. And then after that, we will actually be doing these two activities. We do a pie and burrito chart and a scatter plot activity, and we'll be able to find those all in the book. I'll also place each of these assignments on the calendar for you. Actually, this one is already there. All right, wrapped up. 2.2, it's a good thing. Spend a little time the next 2 days working on that, or 3 days working on that. All right?